Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good day to the panels that will be review my presentation. So for today, I am going to present about my project Sarjana Muda 1, which the title is to design and fabricate a motor assist kayak foot pedal for the fin drive system. Before we started, let me introduce about myself. My name is Mohamad Iman Bin Ismail. My metric number is B091810455. I am from 3 BMMA 2/1 and from Faculty of Mechanical and Manufacturing Technology, which is FTKMP. Okay, next, this is my supervisor, IR Mazlan bin Ahmad Mansor from FTKMP 2. As for introduction, what is kayak? According to Tech Edel 1976 and Rodal 1977, kayaking is a sport activity characterized by exceptional demands on upper body performance. Nowadays, modern kayak have grown into various categories that can be simply classified as river kayaks, sea or touring kayaks, racing kayaks, surf kayaks, fishing kayaks, and recreational kayaks, depending on users intended to use. So next, problem statement. Generally, there are two types of fishing kayak, which is paddle type and paddle drive, which consists of fin drive and propeller drive. It is undeniable that kayaking, apart from being a pleasurable and enjoyable sport, have many health and mental benefits. However, as people get older, their physical well-being, which is strength, stamina, agility, and flexibility drops, making everyday tasks and normal functioning more difficult for the elderly. So next, for the research objectives, because the motor assist drive is just available for the propeller system, therefore the motor assist drive can reduce the energy needed for pedaling kayak from one point to another. So in specific, the objectives are as follows. The first one is to design the motor assist kayak for the fin drive system by using computer-aided three-dimensional interactive application, which is CATIA software. Secondly, to fabricate and innovate the motor assist kayak for the fin drive system by using electrical energy. And the last one is to reduce the conservation of human energy to pedal the kayak. Next, scopes of research. The scopes of research are as follows. First one is to invent the motor assist kayak for the fin drive system by using gear and pulley concepts. Second one, the factor that affect speed and performance of the motor assist kayak. And the last one is the type of power source and motor used to move the fin drive system. Next, literature review based on previous related work. So, we start with the evolution of kayak. In 18th century, kayak was first introduced in Europe. One of these designs was revolutionary collapsible kayak model called a fold boat, which invented in Germany in 18th century. The fold boat was designed to be dismantled and transported in just 2 suitcases. Next, in the 1950s and 1960s, Percy Blandford designed and produced hundreds of canvas-covered plywood and wooden kayaks, which popularized among sea kayaking. Next, 1936 and 1972, kayaking as A competitive sport began during the Summer Olympic Games in Germany 1936 and has since gained international appeal. The first whitewater racing event premiered in 1972, and today the Olympics have more than 10 whitewater competitions. Next, the existing types of kayak propulsion. So basically there are three types of kayak propulsion. The first one is pedal kayak. The pedal is held with two hands, some of distance apart from each other. For normal use, it is drawn through the water from front, which is the bow, and to back, which is the stern, to drive the boat forwards. And the two blades of a kayak pedal are dipped alternately on either side of the kayak. Next, pedal fin drive. A mirage drive is a pedal-powered device that uses two identical fins that move forward, backward, and sideways to make the kayak move. On the water, speed and efficiency are the advantages of pedaling. Next, pedal propeller drive. A propel drive is used to propel a propeller-based pedal kayak forward or backward. The native watercraft first introduced propel drive-based pedal kayak in 2008. The difference between a propel drive and a mirage drive is propel drive consists of rotational pedals that work with a rotating propeller rather than push pedals of mirage drive. Because the propeller is located beneath the kayak, the operational method is simple in this case. When the pedal is rotated, the propeller rotates as well. And as the kayak moves as the propeller turns. Next, the introduction to quick return mechanism. So, a quick return mechanism is a system that creates a reciprocating effect by taking less time in the return stroke than it does in the forward stroke. The working and return stroke of quick return systems have differing input durations. A quick return mechanism's time ratio is the ratio of the input displacement change during working stroke to the change during the return stroke. A rotary motion is turned into linear motion in a quick return mechanism, like a crank or lever mechanism. However, the return stroke is different from the forward stroke duration. The time duration is different between the forward stroke and the return stroke. So this mechanism can be found in various machines such as shaper machine, slotted machine, screw presser, and mechanical actuators. So next, methodology. So the flowchart shows, the general methodology is translated to the flowchart that can be seen in the screen. So I have highlighted a few important in this flowchart, which is the literature review, survey, design, fabrication, data analysis, and report writing. So for the PSM1, we do until the mechanism selection before we do the fabrication. Next, so for the concept design of motor assist foot pedal for the fin drive, basically there are three types of mechanism that will be used in this project, which are quick return, 4-bar linkage, and scotch yoke mechanism. The ideas for motor assist will be converted into raw sketching. So the first one, design A. Design A use a single sprocket that connected to the starter motor, which directly connected to the starter motor. This design using a single bar, which is a single metal bar that connected between the sprocket and the pedal. A short bar will be welded to the sprocket here to make an offset. So basically, when the sprocket rotates at full 360 degrees, the pedal will rotate in a limited range between 0 and less than 180 degrees. The motor used is smaller, that making the bar that connects between the sprocket and the pedal is not linear. So a short bar will be welded to the sprocket to make an offset. Next, for design B, the primary mechanism used is quick return mechanism, which consists of two sprockets, which are a driver sprocket and a driven sprocket. The driver sprocket will be directly connected to the starter motor. However, the driven sprocket will be welded with a short bar that consists of bearing. Then a slotted bar will be joined with the short bar here, and a mounting after applying some grease here to the bearing. Next, the slider is connected to the slotted bar here, and the slider is an optional. Without the slider, the system can perfectly function as well. And the last one is design C. Design C mechanism is using a Scotch yoke mechanism. So this mechanism only requires one disc as the rotary motion, which to convert rotary motion to linear motion. A bar that has been welded to the slotted metal, and the disc will be directly installed to the starter motor, and a roller will be joined to the disc here. And the rear metal bar can be attached to the pedal here, either by using a pin or welding method. Okay, next, preliminary finding. So, as we can see now is the table of product design specification, and the motor assist kayak for the pedal fin drive will be invented by referring design B. This is because design B is much suitable for kayak that will be used in this project. Although the cost of production is not so cheap and affordable, design B is more efficient compared to the others. Moreover, design B is the simplest mechanism compared to the other design that use more storage in kayak cabin. And the main component that will be used in fabrication are sprockets, chains, bearings, hollow metal bar, and C-shaped steel. Next, this is my bachelor's degree project 1 Gantt chart. And as for conclusion, this project will produce a motor assist kayak for foot pedal fin drive system that will minimize the conservation of energy kayak users. Moreover, this project is more to fulfill the objective requirement and solve the problem statement of this project. And that's all from me. Thank you. Have a good day to all panels that will be reviewing my presentation, and I hope for any inquiries, please ask me during the Q&A session. Thank you. Assalamualaikum warahmatullahi wabarakatuh, and have a good day.